Hello students, myself Dr. Sofia Gupta. So today we'll study the topic molecular geometry and VSEPR theory. So before studying the molecular geometry, we'll study what is VSEPR theory. Now the word VSEPR, it stands for valence, shell, electron, pair, repulsion. Okay, so basically this theory tells us about the shape of the molecules. मतलब it helps to predict the shape of a molecule. Now there are 2-3 main postulate of VSEPR theory according to which we will draw the shape of the molecule. So the first postulate is that in a compound we consider one atom as a central atom and the other atoms are linked to this central atom through a bond. Second, the molecule, this is a most important point, the molecule will take that shape in which the repulsion between the electron pair is minimum. Okay, so the order of repulsion is lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. Okay, now to calculate or to predict the structure of a molecule, we should first calculate its hybridization. Okay, so hybridization is calculated through two methods. First is from structure and second is from formula. Now firstly we will discuss first method, that is from structure. Okay, now from the structure, it's a simple method. Like for example, first step you have to follow is that you should know how much the valence electrons the central atom is having. How much the valence electrons the central atom is having. This you should know. This is a main thing. Okay, then you have to calculate a factor known as Z, which is a sum of number of sigma bond plus number of lone pair of electrons. Okay, now sidewise you can draw a table, the value of Z, hybridization and geometry. If the value of Z is 2, the hybridization will be SP and the geometry will be linear. If the value of Z is 3, the hybridization will be SP2 and the geometry will be trigonal planar. If the value of Z is 4, the hybridization will be SP3 and the geometry will be tetrahedral. Similarly, for the value of 5, the hybridization SP3D and the geometry will be trigonal bipyramidal. Then for 6, SP3D2 octahedral. Then similarly for 7, SP3D3, it is pentagonal bipyramidal, right? This table you have to learn. This is a very important table. So let's understand this with the help of an example. For example, you are having SF6. Now the question will come, calculate its hybridization, what is the geometry and what is the shape of a molecule. Okay, now see, firstly what is central atom over here? It is S, that is sulfur. Now sulfur is having 6 valence electron, 1 2 3 4 5 6, right? And 6 fluorines are attached. We know fluorine makes a single bond, that is it's a monovalent atom. So we'll attach 6 fluorine over here. Now our next step is to calculate the Z value, which is sigma plus lone pair. Now how many sigma bonds are there? 1 2 3 4 5 and 6. 6 sigma, 0 lone pair. So Z is 6. Okay. Now for the Z6, the hybridization is sp3d2 and the geometry will be octahedral. Okay. Now you have to note one point which is very important. In case where there is no lone pair of electron present, where there is no lone pair of electron, the geometry will be equal to the shape of the molecule. But if there is lone pair of electrons present, then geometry will be decided by hybridization, while in shape we do not consider lone pair of electron. Consider lone pair of electron. This I'll explain you with an example. Like see, you can take a similar example, SF4, है ना? Previous example it was SF6. Now you can go for SF4. Now sulfur, it is having 6 valence electron, right? 4 with the 4 electron, it will make 4 bonds with the fluorine. So now it is left with one lone pair of electrons. Now what is Z? It is sigma plus lone pair. Sigma here is 4 and lone pair is 1, so Z is 5. So I have told you for the Z5 the hybridization is sp3d and the geometry will be trigonal bipyramidal, right? Now see, trigonal bipyramidal is like this, trigonal bipyramidal, ठीक है? Now see, now the question is where to place this lone pair of electron, ठीक है? Now see, basically these positions which are on the plane are known as equatorial positions, and which are above the plane or below the plane, this is known as axial position, ठीक है? Equatorial are basically more stable, so basically you have to place the lone pair in that where the molecule will be symmetrical after placing the lone pair. For example, in this, when we place a lone pair here and we can place 4 fluorine over here, now its shape will be seesaw, right? Geometry will be determined by its hybridization, so the geometry will be trigonal bipyramidal and the shape will be seesaw. For example, in case like in this you are having just one lone pair of electron, in case you are having 2 lone pair of electron, then you will place in this position, okay? In case you are having 3 lone pair, then you will place 3 over here, and if you are having like this, only maximum cases you can get in the trigonal bipyramidal geometry, okay? Let's do one more example. For example, ClF3 negative. Now the question will come, calculate the hybridization, geometry and shape of this molecule, right? Now, firstly, the first step is to determine the central atom. In this, the central atom is obviously chlorine. Okay, so chlorine, we know it is a halogen group, belongs to the halogen group family. So it will have the valence electron 7. So let's draw that. Now it's having one extra charge, means it have gained one electron. So the total electron around the chlorine will be 8. 3 fluorines are attached. Let's attach by a covalent bond, right? Now you have to calculate Z for it. Z is sigma plus lone pair. Sigma 3. How many lone pairs? 2. Na? So Z is 5. So for 5, we have studied sp3 D geometry. Okay, so this is a hybridization. So the geometry will be trigonal by pyramidal. Now 2 lone pair, I've told you 2 lone pair like this you can place. Okay. Now what will be the shape? Here the shape will be T shape, because in shape we do not count the lone pair, so the shape will be T shape. I hope that is clear. Now, second method to determine the hybridization is formula based. So you can note down the formula. It is half the number of valence electrons around the central atom plus number of monovalent atoms minus the charge on cation and plus the charge on anion, right? Like for example SF6 previously we have done, so we can calculate it by formula also. Hybridization, Z is equal to half, number of valence electron was 6, monovalent atom, fluorine is a monovalent, so 6, no charge, so the hybrid Z comes out to be 6, Z is equal to 6, sp3 D2 will be the hybridization, geometry will be octahedral and shape will be octahedral. I hope the concept of VSEPR theory and how to determine the molecular geometry is clear. If you're having any doubts, then you can pin down in the comment section. Thank you.